Hi students, I am Aruna, lecturer in computer science, Sasria College for Elder. In this video, I am going to explain about binary tree implementations. With an example program, we will construct a binary tree and use different traversal techniques. This is the continuation topic for the previous video. Binary tree. A binary tree is a recursive data structure where each node can have two children at most. It means it has maximum of two children. It should not exceed more than two children. Just recollect the previous definition. A tree is a non-linear data structure in which every node can have more than two childs, whereas a binary tree is maximum of only two children, either 0 childs or 1 child or 2 children. It should not exceed 2. It has maximum of 2 or at most 2 children. See the figure for this binary tree structure. A root node 1 with left child 2 and right child 3. Again 2 is having a left child 4. Binary tree implementation. How we implement these binary trees? With the help of pointers. The first node in our tree is represented with a root node. The first node in a tree representation is represented by the root pointer. Each node in a tree consists of three parts, that is data, left pointer and right pointer. To create a binary trees, what we need? First we need to create a node. Without a node we can't construct a tree. So initially we must construct a node. Then the node is attached to another nodes, or we can extend the tree structure. We will create the node of user defined as shown below, like a public class, binary tree, node with a root. Here I created a node, initial node. That starting node of the tree is usually called the root node. Now the value in the root node is the data. It has a left child and a right child. This is our program for inserting values in a binary tree structure. How we are going to insert these values in a binary tree? As I said, first we need to create a node. For that, class node int key. Objects of class type node are left and right. Public node int item key equals to item, left equals to right equals to null. If I want to enter a value in that node, then item is the key value with left and right childs as null. The first node is a root. In a binary tree I constructed a root equals to new node of key value. Now the initial node that is created or else inserted in a tree structure will become the root. That is, here I created a tree object for a class binary tree. Now the object for accessing this binary tree is tree. Tree dot root equals to new node of 1. Now the item or else key value is 1, with the left and right childs as null. A node is created with value 1 and left child and right child are null. This is the initial node. That's why we are creating tree dot root equals to. Now the root left child and right child are null. Now I want to insert another node with a value 2. And these 2 should be the left child for this root node 1. For that we have to write tree dot root dot left equals to new node of 2. Similarly, node 3 as right child for the existing root node. Tree dot root dot right equals to new node of 3. If I want to extend the tree, that means now 2 and 3 are parent nodes. If I want to extend, then how many nodes it has? In the definition we learned that a binary tree is recursive data structure. We can treat these 2 as parent node, and again this parent node will have left and right childs. Now I want to create a new node for this existing node. Now the current node is 2 or consider as 3. If I want to insert a new node under left child or right child, here I have written for left child. If I want to place it a left child for the right node, that means node 3, then we have to write tree dot root dot right dot left. If I want to place it as a right node for the right node, then tree dot root dot right. Now 4 is the right child for 3. Here I constructed this node 4 as left child for node 2. Okay. This is the tree structure, how it is created according to our program execution. Main method, initial node is root node, tree dot root node. Root is created with the node value 1. Now 1 doesn't have a left child and a right child. Now I am creating a left child for this root node. Then we have to write tree dot root dot left equals to new of node 2. Then 2 will become a left child for this root node 1. Similarly 3. If you observe here, 2 and 3 will become the left and right children of 1. When I inserted these 2 nodes for node 1 as left and right childs. Similarly, I want to insert another node in the structure, that is tree dot root dot left new equals to node of 4. Then 4 becomes the left child of 2. If I want to construct 4 as a right child for 3, then we have to write tree dot root dot right dot left. Okay, this is the final output of our code. If you observe the code, the above code is calling a create function recursively, and creating a new node on each recursive call, we construct this binary tree. How we will traverse these trees? That is traversing binary trees. Traversing means visiting each node in a specific order. This process is not as commonly used as finding, inserting and deleting nodes. One of the reasons for this is traversing is not particularly fast, but traversing a tree is useful for some circumstances. The degree or number of children a node has in a binary tree is maximum of 2 children. When all the nodes are created, then it forms a binary tree structure. Any node in a binary tree data structure can reach by starting at the root node and repeatedly following the references to either the left or the right childs of the root node. This process of visiting all the nodes is known as tree traversal. We can traverse the tree in 3 different ways. The 3 types of traversals are preorder traversal, postorder traversal, inorder traversal. Consider the figure. Now I am going to explain this traversing with this diagram for preorder traversal, post and inorder. Write it down. We have to compare the tree for each traversal. Okay. First type of traversal is preorder traversal. In a preorder traversal, we visit any given node before we visit its children. So first we have to visit the root, and then here we begin the root node with 7 and end at the rightmost node, that is 10. Traverse the left subtree and then traverse the right subtree. So first we have to visit a root node, then left subtree, finally the right subtree. First one is root or parent. Root, left, then right. First we have to process the root, then travel the left subtree recursively on left children and travel the right subtree on recursing right childs of the subtree. This is the code for printing preorder nodes in a binary tree. If there are no values or nodes in a tree, then it will return null. If there exists a node, then it will print that node. Later it will call the left subtree, then right subtree. So it will print the node value, then calls the preorder method, that is for left subtree, and then call the preorder method for right subtree. In this, the traversing sequence in this case would be 7, 1, 0, 3, 2, 5, 4, 6, 9, 8, 10. Recollect the figure. 7 is our root node. So first we have to visit a root and then traverse left subtree. Left subtree of 7 is 1, and we have to recursively call the left subtree. Now 1 is having a left subtree 0. 0 doesn't have any subtrees. Then go for the right, travel for the right subtree. Now our current parent is 1 with left child 0 and right child 3. Again node 3 is having a left child 2. 2 doesn't have any left childs. Again it will go for traversing right subtree. The right subtree of 3 is 5. Next, our current node is 5. We are going to traverse left tree for node 5 is 4 and the right subtree is 6. There are no left subtree and right subtree. Then go for the parent. The left subtree is almost done, and now we will travel a right submost tree. That is a root right node is 9 and it is having left child 8 and right child 10. The order for preorder traversal is root, left and right. And then next traversal is postorder. In preorder, we first visited the root node and then left subtree and then right subtree. In postorder traversal, we first visit each node after visiting its children and their subtrees. We begin with leftmost node and end with root. So in our diagram, our root node is, leftmost node is 0 and the root node is 7. So our postorder traversal traverse the left subtree first and then right subtree, finally visit the root. Coding part for this postorder. First we have to travel left subtree and its children subtrees. Then it prints the right subtree. Finally it will print the root node. For this traversal sequence, in this case is figure for a postorder traversal. So in postorder, first we have to visit left subtree and its children subtrees. So our left subtree is 0. 0 is left subtree for 1. So if I want to represent root, then we have to traverse the right child of the parent after left. Now I finish left with 0. Then go for the right, that is 3. Before right we have to do left. Then the next element after the 0 will be 2. Similarly 4, 6. Now 4 and 6 are left and right childs of 5. Two and 5 are the left and right children of 3. 0 and 3 are the left and right childs of 1. Okay, 0, 2, 4, 6, 5, 3, 1. Now we traversed entire left subtree. Now we have to traverse right subtree. So our right subtree is 9 with left child 8 and right child 10. Again we have to begin with left subtree. The left subtree for 9 is 8. The right subtree is 10. Then root. Finally the root 7. Okay. The next type of traversal is Inorder traversal. In pre and post orders, we traverse first left subtree, then right subtree, then root, or else root, left subtree and right subtree. Whereas in Inorder tree, we first visit the left child, then visit the parent node, and then finally visit the right child, including its entire subtree. Inorder traversal first traverse the left subtree, then it will visit the root node, then traverse the right subtree. So in Inorder traversal, you first visit the left subtree, then root, finally right subtree. That's why left, root, right. Here we begin at leftmost node 0 and end at rightmost node 10. So this This is the code for printing Inorder nodes. First left subtree traversing, then data, then recursively calling the right subtree. The traversal sequence in this case would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Note that the binary search tree makes the use of Inorder traversal method to print all the nodes in ascending order of value. Let's see the output for these all traversal techniques and the tree structure. Let's run this is our program with the 3 traversal techniques like Inorder, Preorder, Postorder. For before calling a create method, we have to create a node. Initially I created a node, then a binary tree with the postorder. The order for postorder is traverse the left, traverse the right subtree, finally print the data. For Inorder, traverse the left tree, print the data, traverse the right tree. Preorder, first print the data, then recursion on left subtree, then recursion on right subtree. Binary tree with an object tree and inserted values 1, 2, 3, 4, 5. This is our program. Let's see the output for this program. This is our program. Let's see the output for this program. This is the output for this binary tree construction. I constructed a binary tree with values 1, 2, 3, 4, 5. If I traverse this binary tree in pre-order, we will get 1, 2, 4, 5, 3. If it is in order traversal, we will get 4, 2, 5, 1, 3. If it is post order traversal, 4, 5, 2, 3, 1. This is our finally constructed boundary tree with these nodes. Thank you.